Number 5. All right, we're getting into some two-parters here. We're using some new stuff. So, a little new stuff going on here. Let's check it out. At standard temperature and pressure. Again, we haven't done this a lot. This is actually more of a chapter 10 thing. All I'm doing is I'm going to give you a real short introduction of a new statement of equality. See how that says it's equal? Statement of equality. To use as a conversion factor. That's all it is. I'm allowed now to equate moles to volume. Perfect. So, 1 mole of any gas takes up 22.4 liters of space. Okay, that's our statement of equality. That's what we're going to be using. A, what mass of oxygen, okay, mass of oxygen is produced if 100 grams of lithium perchlorate are heated and allowed to decompose according to the following equation. So here's the lithium perchlorate. I'm being asked how much oxygen in grams is being produced. So I am going to set up by starting with the given, the mass of lithium perchlorate. I'm going to have to convert out of grams of lithium perchlorate and into moles of lithium perchlorate so that I can use the mole ratio of lithium perchlorate to what I'm being asked for, which is O2. Now the question is asking for a mass, so I have to slap on a conversion factor using the molar mass of O2 in order to get into the correct units. Now when I'm done, my units need to be in grams of O2 because that's what the question is asking for. I can cancel my grams of lithium perchlorate, I can cancel my moles of lithium perchlorate, and I can cancel my moles of O2, leaving only the mass of oxygen. So it's looking pretty good to start. So let's start plugging in some numbers that we have. That's 3 significant figures, by the way. So my answer will probably need to have 3 significant figures. For every 1 mole of lithium perchlorate, ooh, we need a molar mass. Let's calculate a molar mass here. Periodic table, come to save me. So we have a lithium coming in at 6.941. I got a chlorine. Is way over here. 35.453. And then 4 oxygens. Oh my gosh. At 16 a pop, comes out to be 64. Alright, I'm going to use the calculator on that ugly mess. 6.941 plus 35.453 plus 64. Holy cow. 106.4. Okay, let's just keep it simple so my numbers don't get too big for my conversion factors. Don't you hate it when you have messy math? Alright, now I'm on to the mole ratio here of the lithium perchlorate. That coefficient is 1 to oxygen. That coefficient is 2. 1 mole of O2 is coming in at 32.00 grams. If you don't believe me, check your periodic table. Now I'm in a position where I can simply plug and chug. So 100 times 1 times 2 times 32 divided by 106.4 divided by 1 divided by 1. Now the question had me start with 3 significant figures, so my answer is going to be in 3 significant figures. This is actually giving me a bunch of extra, so I need to actually round this tenths spot up 1. So I'm going to report 60.2 grams per mole. Alright, 60.2 grams per mole for my final answer for part A. Part B. The oxygen gas produced in part A, that, has a density of 1.43 grams per liter. Calculate the volume of this gas, using the new standard of equality given at the beginning of this question. That one. Okay, that one. So that means I'm starting with what I generated in part A, 60.2 grams of O2. Now, you might be a little bit confused about how to use this. Well, in the exact same way we use molar mass, we use density. We can cancel out of grams and go into liters, which is a unit of volume, okay, volume. So I need to cancel out of grams of O2, and this allows me to go out of grams and into liters. So on the numerator, we'll have liters. Notice that I can cancel my grams, and I'm only left with liters. Hooray! But what numbers do we plug in here? This says per liter. That means per 1 liter. How many grams per 1 liter? 1.43. So into the calculator, I simply type 60.2 divided by 1.43. Now, I started with 3 significant figures because I'm pulling 3 significant figures from part A. And I got 3 significant figures here, so I'm going to stick with 3 significant figures. This 9 in the 100th spot tells me to roll that 10th spot up to a 1. So I will report 42.1 liters of O2. Now, we haven't done a whole bunch of density calculations recently. We certainly haven't used like standard molar volume, but you don't have to know what those are because we're simply learning how to set up crosshairs, right? That factor label method of dimensional analysis to cancel out of units that we want to cancel and move into units that we want to report our answers in terms of.